Hi everyone, this is going to be the second PowerPoint on the strengths and weaknesses of different research methods. And in this PowerPoint, I'm going to talk about correlational studies, experiments, and quasi-experiments, as I'm going to talk a little bit about how we should interpret group differences. Let's begin by talking about correlational studies. And in correlational studies, participant scores on two variables are measured without manipulating them to determine whether a relationship exists between those variables. What I mean by not manipulating them is that the researchers would just measure their scores on those variables. You're just observing what's already there and not assigning people to groups. Here's an example of a correlational study dealing with height and weight. Right? Each dot would represent the height and weight of one particular person in your study. The y-axis is for weight, which ranges from 80 pounds to 200 pounds, and the x-axis is for height, which ranges from 60 inches up to 76 inches. So yeah, as you go higher up the y-axis or towards the right on the x-axis, the people's scores increase. Notice that we're not changing people's weight and seeing if that changes their height, right? We're just measuring things. Neither of these variables are being manipulated. We're just measuring the height and the weight of our participants. And in this case, we would say that there's a positive correlation between these variables. As people's height increases, so does their weight. As another example, let's say we want to run a correlational study to see if there's a relationship between the amount of time people spend playing video games and a person's level of aggression. To run such a study, you would simply ask, let's say 50 people, how many hours of video games they play each week, and then record their scores for a measure of aggression. Notice that you don't assign some people to play 5 hours of video games a week and others to play 15 hours. You just measure what's already happening. So the main strength of correlational studies is that they allow for a quantitative examination of the relationship between variables. The idea is that when you have two variables that you're interested in exploring, it's almost always possible to come up with a correlational method to investigate them. So for instance, let's say you want to see if there's a relationship between the amount of graffiti in a city and its crime rate. The mayor probably won't let you spray massive amounts of graffiti all over her city, but you can always observe what's already there. You can always measure the amount of graffiti in a city and then determine its crime rate to see if there's a relationship between those variables. The main weakness with correlational studies is that one cannot conclude that changes in one variable are causing changes in another variable, even if a relationship exists between those variables. So let's say that we do find a correlation between the amount of violent video games played and a person's level of aggression. Can we conclude then that playing violent video games causes an increase in aggression? Well, the answer is no, you can't. The reason is that it could be it's people who are just naturally aggressive that spend more time playing violent video games, or it could be people who play violent video games also watch violent movies, and it's actually watching violent movies that's causing the increase in aggression. So there are other possible explanations for this relationship that our correlational study can't rule out, which is why you can't conclude that one variable is causing the changes in the other variable. I'll have more to say about this weakness over the next couple slides. Just to give you one more example of this limitation, a study of the factors related to the use of contraceptive devices in Taiwan was conducted a couple years ago. The researchers wanted to know which variables best predicted the use of birth control. Any guesses from you guys as to which variable was most highly correlated with the use of contraceptive devices by women? It's sort of a tricky one, so take a guess. I'm sure you're going to be wrong. It was actually the number of electrical appliances in the household. So, given this finding, do you think that buying a couple of toasters for each high school girl in Taiwan would be a good way to reduce the number of unwanted pregnancies? Well, probably not, but why not when we just said that there was a correlation between those variables? Well, stating that a free toaster program would reduce the number of pregnancies implies that the variables are causally related to each other, that changing the number of toasters will necessarily influence the number of pregnancies. Instead, the variables are probably related in a non-causal way. So what's likely responsible for this relationship is probably socioeconomic status, that richer women can afford more electrical appliances and are also more educated about the use of birth control. So just so we're clear then, one cannot conclude that changes in one variable are causing changes in another variable, even if a relationship exists between them, if someone uses a correlational study. So that's what I want to spend some more time talking about now, the reasons why correlation doesn't equal causation. To get into this topic, we're going to talk about 3 requirements for causation. So these are going to be 3 requirements that have to be met before we can conclude that changes in one variable are causing changes in another variable. We're going to see that correlational studies do meet one of these requirements, but not the second 2 requirements. So the first requirement for showing causation is covariation. That is, 2 events must change together or show a relationship which correlational studies are able to determine. So correlational studies do test to see whether variables covary. That is, they do test to see whether there is a relationship. In the violent video game example, if we find the people who play more hours of violent video games are more aggressive, that's covariation. Similarly, in the birth control example, there was covariation between the number of electrical appliances a woman owns and her use of contraception. So correlational studies can be used to show covariation. Here are some more examples of covariation between variables without causation. So in these graphs, what we're going to see is that 2 variables are related to each other. As scores on one variable increase, so do scores on the other variable. So that's covariation. But there's probably not a causal relationship between these variables, right? Changing the scores on one variable isn't causing the scores in the other variable to change. In this first example, we're looking at U.S. suicides by hanging, strangulation, and suffocation, and U.S. spending on science, space, and technology. So we see covariation in this example. We see a relationship, but it's probably not a causal relationship. Spending money on science and space and technology is not causing people to be more likely to commit suicide. Here's another example. We're looking at the relationship between the divorce rates in Maine and per capita consumption of margarine in the United States. Same thing, we have covariation. As scores in one variable change, the scores in the other variable change as well, but there's no causation. It's not like people eating more margarine causes people in Maine to become divorced. What about this example? The per capita consumption of mozzarella cheese in the United States and the civil engineering doctorates awarded in the United States. Again, here we see covariation. As one variable changes, so does the other, but it's probably not a causal relationship. No one thinks that eating cheese makes it easier for you to get an engineering degree. And then finally, we see a relationship between the number of people who drowned by falling into a swimming pool and the number of films Nicolas Cage appeared in a given year. Do we really think that seeing Nicolas Cage in more movies causes people to want to drown? Okay, well, that might be the case. So there might be causation here, but again, the point is we see covariation. We see as one variable changes, the other variable changes as well. But yeah, it's probably not a causal relationship. So you can have covariation without causation. So just to reiterate, correlational studies can show covariation between 2 variables. However, showing covariation is not sufficient to conclude that there is a causal relationship between those variables. Instead, you also have to show 2 more things, which correlational studies cannot determine. So the next requirement for showing causation is time order. That is, it must be clear which variable changes first to cause the change in the other, which correlational studies can't determine. And this limitation, this requirement, is sometimes called the directionality problem, because again, correlational studies can't show this. So time order is the first reason that correlation doesn't equal causation. This would be like our argument that naturally aggressive people prefer playing lots of video games. So it's not that playing more video games causes the increase in aggression, it's that being naturally more aggressive causes people to spend more time playing violent video games. The issue is that we can't tell which of these is true from our data. We can see that there's a correlation between these variables, but we can't tell from our study if it's playing violent video games causes an increase in aggression, or whether it's being naturally more aggressive causes people to spend more time playing violent video games. And because we can't tell which one is going on, we can't conclude causation. To give you another example, a study of ornithologists in the Czech Republic found a relationship between productivity and the amount of beer consumed. So specifically, people who drank more beer were less successful. The New York Times got a hold of this article and concluded that drinking beer causes a reduction in productivity, with people drinking instead of working. But what's another possibility? Well, it could also be the case that people who are just bad at their job drink more beer to keep themselves from feeling miserable. So, because correlational studies can't determine which variable is changing first, and is thus causing the change in the other variable, they can't be used to determine causation, right? We see a relationship between beer drinking and not being very productive at work, but we don't know which variable is causing the change in the other variable. The third requirement for determining causation is the elimination of alternative explanations. That is, no other variable may be responsible for the relationship which correlational studies cannot rule out. And this is sometimes called the third variable problem. So yes, the elimination of alternative explanations is the second reason that correlation doesn't equal causation, because correlational studies can't rule this out. This is what was demonstrated by our toaster study, right? Another variable other than the number of toasters was causing differences in pregnancy rates, right? It was a socioeconomic status that was responsible for the relationship that caused the increase in number of electrical appliances in the house, as well as the decrease in pregnancy rates. The classic example of the third variable problem is that there is a correlation between the consumption of ice cream and the murder rate. So, what do you think is responsible for this relationship? Do you think that eating Ben & Jerry's causes people to go on rampages? Well, probably not. Instead, there's a third variable that is responsible: heat. That is, during the summer, the murder rate increases as people spend more time outdoors together, and that's when ice cream sales increase. So again, because correlational studies can't rule out the existence of a third variable being responsible for the relationship, they can't be used to determine causation. If it helps, here's a nice summary of the issue. Empirically observed covariation is a necessary but not sufficient condition for causality. The next kind of study we're going to talk about are experiments. Experiments are a research study with two key features. The first key feature of experiments is the manipulation of an independent variable with a measuring of a dependent variable. Manipulation means to choose a value for the variable, and this is the main difference between experiments and correlational studies, where the variables are just measured. So let's use our example of video games and aggression. If we were to run this kind of study using an experiment, we would have the independent variable be the number of hours a week people spend playing video games. We might assign half of our participants to play 2 hours of video games a week and the other half to play 10 hours of video games a week. That's what it means to manipulate an independent variable. And then the dependent variable would be the variable we measure, in this case, people's levels of aggression. So we're measuring the dependent variable level of aggression to see whether there are any differences in the values of our independent variable. Any differences between the aggression level of the 2 and the 10-hour-a-week players. So yes, the independent variable is the variable the researcher measures the values for, and the dependent variable is the variable participants' performance is actually measured on. So to give you one more example, to test the effectiveness of a drug on treating depression, we might have 3 groups of participants take different doses of the drug, either 0 milligrams, 10 milligrams, or 20 milligrams, and then we'd measure each group's level of depression after 3 months. So in this example, the independent variable would be drug dose, and the dependent variable would be depression level. The other key feature of experiments is random assignment. And with random assignment, each participant has an equal chance of being assigned to each value of the independent variable. Random assignment means that if we have, let's say, 100 participants in our study, that each of our participants has a chance to play either 2 hours of video games a week or 10 hours of video games a week, or they have an equal chance to be in the 0 milligram group, the 10 milligram group, or the 20 milligram group of the drug. So note that random assignment is not random selection from the population. That's different. What we're talking about with random assignment is random assignment into groups. That once participants have already been selected to participate, they have an equal chance of being assigned to each group or each value of the independent variable. So just to make sure we understand all of those terms, let's go through an example. So in this example, we want to study the effects of a vegetarian versus a mixed diet on blood pressure in a sample of 100 adults. So first, what is the independent variable in this study? What variable are we manipulating or choosing the values for? So in this example, the independent variable is diet type. So we're choosing which diet type participants in our study will eat or receive. Okay, what are the values of the independent variable? In other words, what are the different diet types being used in this study? So that would be a vegetarian versus a mixed diet. Again, those are the specific types of diets. Then what is the dependent variable? What variable is being measured? Okay, well, that would be participants' blood pressure. So we are manipulating diet type. We are assigning people to eat different diets and then measuring their blood pressure to see if diet type affects people's blood pressure. And then finally, how is random assignment used in this study? So the way random assignment is used is, again, to assign participants to groups randomly. So they have a 50% chance of being assigned to either the vegetarian or the mixed group. So specifically, out of the 100 adults in the study, 50 of them will be selected at random to eat a vegetarian diet, and the other 50 will eat the mixed diet. The strength of experiments is that experiments are the only method that allow causal conclusions to be made, that differences in the dependent variable are caused by differences in the independent variable. Again, we can't do this with correlational studies, but we can do it with experiments. The reason why is something called the logic of experimentation, which is this. Random assignment ensures that the only difference between groups is the value of the independent variable that they receive. And so, any difference between groups in the dependent variable must be caused by the difference in the independent variable. So as long as random assignment is used, and the only difference between the two groups is the level of the independent variable that they receive, if they differ on the dependent variable, then the only possibility is that the difference is caused by the independent variable. And that's where you can conclude causation through experiments. However, there is one caveat. This is not true if there is a confounding variable, which is a variable other than the independent variable that the groups differ on. That is, participants might show differences in the dependent variable across the different values of the independent variable, but if participants also differ on some other variable, you can't be sure that it's the independent variable that's causing the difference. That is, if there is a confound, it is impossible to tell whether a difference between the groups on the dependent variable is caused by the difference in the independent variable or the difference on the confounding variable. The best way to demonstrate the effects of confounding variables and how when they're present you can't conclude causation is to go over an example. So let's do that now. So in this example, to study the effects of caffeine on puzzle completion, participants are randomly assigned to receive either 0 milligrams or 200 milligrams of caffeine. The 0 milligram group is run in the morning, and the 200 milligram group is run in the afternoon. I find that the 200 milligram group completes the puzzle faster than the 0 milligram group. So first, let's go through our questions from before. In this example, what is the independent variable? Which variable are we manipulating or choosing the values for? Well, that's going to be caffeine dose. And then what are the specific values of the independent variable? What are the specific amounts of caffeine that we're going to give participants? Either 0 milligrams or 200 milligrams. And then finally, what's the dependent variable? What variable are we measuring? In this example, it's going to be puzzle completion time. So in this case, we're finding that the independent variable does affect the dependent variable. I find the 200 milligram group completes the puzzle faster than the 0 milligram group. However, in this example, we can't conclude causation. So why not? Why can't we conclude that caffeine causes increases in performance in this experiment? Well, it's because there's a confound present. So specifically, there's a confound between drug dose of caffeine and time of day. All of the participants who got 0 milligrams of caffeine went in the morning, and all of the participants who got 200 milligrams of caffeine went in the afternoon. And so the issue is that it's impossible to tell whether the speed increase in puzzle completion is caused by the drug dose, the independent variable, or the time of day when participants completed the task, the confounding variable. And so because of this, you can't conclude that it was the independent variable that caused the increase in puzzle completion speed, because it could have just as likely been the confounding variable. And so the weakness of experiments is that not all research questions can be examined using experiments for practical and ethical reasons. So for instance, let's say we want to know whether child abuse causes adult pathology. Normally, a researcher would compare adults who were abused as children to those who weren't abused as children, so there's no random assignment, right? The groups are sort of already predetermined. But if you wanted to run this as an actual experiment, how would we set up the experiment? Well, it would be very unethical, right? We would randomly assign some children to be abused while other children weren't abused. That's clearly unethical, not something we would be able to do as an experiment. Or if we wanted to compare the depression scores of high school boys versus high school girls, we can't randomly assign someone to be a boy versus a girl, right? They are who they are. And so it would be impossible to use an experiment to examine this question. Well, this brings us to our last kind of research method, which is quasi-experiments. In quasi-experiments, groups of subjects who already differ on some variable are compared to see if they differ on a second variable. And so we can use quasi-experiments to compare groups of people who already differ on a variable like gender to see if they differ on another variable like depression. You can use a quasi-experiment also to compare a group of adults who were abused as children to a group of adults who were not abused as children, again to see if they differ on some trait. Essentially then, quasi-experiments are like experiments, except that random assignment is not used. So again, with experiments, we are randomly assigning participants to get different values of the independent variable, but in quasi-experiments, the group differences sort of already exist, so no random assignment is used. The main strength of quasi-experiments is that they allow for variables to be examined when true experiments can't be performed. So for example, let's say we want to test to see whether there is a difference in SAT scores between public versus private high school students. Well, we cannot run a true experiment to try to answer this question because we simply can't randomly assign students to attend either public high schools or private high schools. But instead, what we can do is to run a quasi-experiment where we compare group differences where the groups already exist. So we compare a pre-existing group of private school students to a pre-existing group of public school students to test to see if there are any differences in their SAT scores. However, this brings us to the main weakness of quasi-experiments, that because no random assignment is used, if a difference is found between the groups, it is not correct to conclude that the assignment variable is causing the difference. In other words, even if we do find that private school students, let's just say, do have higher SAT scores than public school students, we can't conclude that school type is causing the differences. And this is because there are other differences between private school students and public school students, such as their parents' socioeconomic status, that could be responsible for that could be causing the difference in SAT scores. So again, because there is no random assignment, we can't conclude causation with quasi-experiments. The last thing I want to talk about on this PowerPoint is interpreting group differences. So what I'm going to do is to read you two sentences, and I want you to determine which sentence, if either, is true. Okay, the first sentence, men are taller than women. Is that sentence true? Well, I would say yes, that's definitely true. Here's some hypothetical data, but they're probably pretty accurate, right? So in this graph, we're looking at the distribution of heights for women and the distribution of heights for men, and we can see that, yeah, men are taller than women. Okay, but what about this statement? All men are taller than all women. Is that statement true? Well, no. And clearly it's not true, and if we believe these data, we can see that there are definitely women that are taller than some men. The point I'm trying to make is that these two sentences, men are taller than women, and all men are taller than all women, are not the same. One sentence is correct, that men are taller than women, while the other sentence is not correct, that all men are taller than all women. What I'm trying to get at here is what is the correct way to interpret group differences. So this is the point I'm trying to get across. Finding a difference between groups means that the average score of one group is higher than the average score of the other group. So yeah, to say men are taller than women just means that the average height of males is larger than the average height of females, or that the average man is taller than the average woman. That's all it means when we say that there's a difference between groups. The issue is that when it comes to applying this logic to the results of studies, students seem reluctant to do so because I think they believe that we're saying something that we're not. So it does not mean, for instance, that if you find a group difference, that the scores of every individual in one group will be higher than the score of every individual in the other group. So I'm going to read some sentences, and I want you to figure out what they are not saying and what they are saying. Our first sentence is, children with ADHD get lower grades than children without ADHD. So first of all, what is the sentence not saying? Okay, so it's not saying that every child with ADHD will get lower grades than every child without ADHD. What it is saying is that on average, children with ADHD will get lower grades than children without ADHD, or that the average child with ADHD will get lower grades than the average child without ADHD. Okay, let's try another one. Prozac is an effective antidepressant versus a placebo. So what is it not saying, and then what is it saying? Okay, it's not saying that every person who takes Prozac will have a lower depression score than someone who just takes a placebo. Just that on average, people who take Prozac will have a lower depression score than those who take a placebo. And then finally, scholastic success is related to socioeconomic status. Okay, it's not saying that every successful student is going to become a millionaire while every non-successful student won't. It's just that on average, those people who attend college and do well will earn more money than those who don't. All right, that's all I have for you guys this week.